Right. So this is irrelevant. All right. All right. Got him. Here we go. So I'm going to show you a couple things here. Stay with me. Silence. Shh. All right. I'm going to show you images of solids, liquids, and gases just so you can see a different image than what we drew. First thing you're going to see is a solid, then a liquid, then a gas. Then I'm going to show you two things that are kind of weird, and you'll understand in a little bit. All right, so there's a solid. What are those lines representing?
Vibration.
Right, solids are vibrating, okay? So don't forget that, because I forgot to tell you yesterday. Again, I apologize. So there's your solid, nice ordered rows, compact, crystalline solid. Liquids. Now, it's an okay image. These spaces are way too big. Solid particles and liquid particles are basically the same distance. If this is a solid, they're just sitting here vibrating. If it's a liquid, they're moving around each other, but the distance really doesn't change. So it's not a great image, but it's good because I need you to understand that they're slightly further apart than solids, but it's so slight it's kind of hard to explain that, I guess. But anyways, there's a liquid. Gas, I got a video of gas particles moving. I want you to pay attention to how they move. So watch one of them. So watch that one right there.
Wow.
Or this one down here. Whoops. Or that one. Or those. See if those two are going to stay together or if they're going to part like two ships passing in the night. Here we go.
Yeah.
Good luck.
Let's watch that.
Find this one right there. You can find that guy. Here it is.
Get out the way.
Just notice how they're moving, okay? Notice how they're moving. And I used the analogy of golf this morning. If you've ever hit a golf ball, there's usually one of three things that can happen, usually. It can kind of go straight, or you can slice it, or you can hook it. And there's other crazy things that can happen. But in general, that's what happens. So here's my question to you guys. If these were all golf balls that you're hitting on your drive, are they going straight, or are they hooking, or are they slicing?
Yes.
Yeah.
They're all doing the same thing. What are they doing? They're moving straight.
Yeah.
They're moving in straight lines. They don't curve, okay? There is an actual law, theory, I should say, kinetic molecular theory, that gas particles always move in straight lines. So right now, the gas in this room are moving in straight lines. So that's something you need to remember. Gas particles are moving randomly, very far apart, right? But in straight lines. And what happens when they collide with something?
Boom.
They bounce off.
They bounce into their path changes, right? And boom, maybe. We'll talk about the boom later. All right. Okay. Observe my bedroom.
You're funny.
You wish.
How do you know that's not my bedroom?
You work at first.
What does that have to do with anything? Just because I work here, that doesn't mean I can't have that. What if that was literally the entire place that I live in, just that room? Would that be more fun?
I don't even see a fridge.
All right, it's behind that weird wall over there.
Oh, so
the
you
bathroom's
got
there.
one of those rooms
Everything.
that
All right.
covers everything else.
So this is one room. Pay attention. This room has very low entropy. That's a word you're going to write down. Entropy. Let's write it down right now.
Writing it down.
E-N-T-R-O-P-Y. Entropy. It's a real important word. Probably should have used it as one of the words of the week, but that's okay. So this has low entropy. Low entropy. Now,
It's probably mine.
got a picture of Kieran's room here.
Oh my god, that's mine.
Okay? So Kieran's room.
Yeah, it's kind of accurate.
Liam got him that purse for Christmas.
No, he just beat me with it, and that's weird.
Yeah, the only reason I'm calling you out is because in period 2 today, I forget who I used. I said, oh, this is so-and-so's room, and then someone's like, oh, maybe that's Kieran's room.
Tyler Boyd said that.
They called you out. So, anyways, so this room has high entropy. So, I'm going to ask you, think about it. If this is high entropy, and then this room is low entropy, don't say it, I want you to think, what could a definition of that word be? So low entropy here, and then high entropy here. So just think for a little bit. I'm going to give you another example while you're thinking. Right now, you have very low entropy. When the bell rings, everybody gets up and goes wherever you're going, the hallways will have high entropy. So right now, low entropy, bell rings, that'll be high entropy. So again, high entropy, low entropy. Hopefully you had enough time to think while I was talking. Monica, what do you think?
Would low entropy be like a lot of order in order to move around?
Good. I like that word, order. So low entropy means a lot of order. Very good. So then what's high entropy? Chaos, or give me another, the opposite of order. Which is chaos, but disorder. Disorder, very good. So what is entropy?
Order, level of order.
Who said that? The level of order.
Well,
The level of order. Yes, very good. I'm going to write it a little different. You can write that. But the definition in the book, I think, will say something like this. The degree of disorder. Degree of disorder. So, solid, liquid, gas. Olivia. Which one has the highest entropy?
gas.
Very good. So gases have high entropy, right? Gas has high entropy. And low entropy would be? Anybody?
Solid.
Solid. Solid. Sorry, my marker's dying here. Low entropy. So who has a room more like this one? Like neat, orderly? Okay, just kidding. No shot, Trevor. No shot.
I do.
This has got to be you, right?
That is so me.
Ah, Lord.
Who has this?
Me. Yeah.
Like seriously, this bad?
I'm.
No, I just got clothes all over the floor.
Yeah, I have a bunch of clothes.
I think when I was in high school, I was probably more towards the neat. A little bit. All right. Grab glasses. Meet me at the fume hood.
Anywhere in my room, you will find me.
I just told you.